In this video, we're going to look at the language and notation of integer exponents. Represent the given exponential expressions in the four ways indicated. So just as a review, we're going to start with a positive number raised to an exponent. So remember, this means 6 squared. So let's write the word name first. 6 squared, or we may say 6 to the second power. And what this means is that we're going to multiply the base 6 by itself 2 times. So we have 6 times 6. Factor language is when we say that we are finding 2 factors of 6. So this word factors is supposed to remind you that you're multiplying these two numbers, you're not adding them. So if we wanted 2 times 6, that would be 2 copies of 6. We would be adding 6 to itself twice. That's what multiplication is. Exponents means we're multiplying the number by itself, the exponent number of times. And as a math equation, we'll find 6 times 6, which is 36, and we'll write 6 squared equals 36. Okay. So now it can be a little bit tricky when we have either this is actually going to be an opposite sign or a negative sign involved when we have exponents. So when we have the opposite of 6 squared, that's actually how we'd say this. The opposite of 6 squared. The question arises, are we squaring this opposite sign? Are we thinking of this as a negative sign that we're squaring? And the answer is we can really think of it, or we do think of this notation as -1 times 6 squared. And since we perform exponents first, we are just squaring the 6. We're not squaring a -6. So the opposite sign stays out front. So we're going to write this as the opposite of 6 times 6. And that's why this language is so useful. Okay, so we're not squaring -6. We're taking the opposite of the result of multiplying 6 by itself. In factor language, we'd write the opposite of 2 factors of 6. And we saw if you have 2 factors of 6, it's 36. So the opposite of 2 factors of 6 is -36. Let's look at the next one. Now here, notice this is a -6. Because it's in parentheses, we are squaring -6. We are not thinking of this as the opposite of 6. Okay, so our word name, we'd say -6 squared. So this means we want 2 factors of -6, so we're going to multiply -6 by itself twice. Or you could also think of this as -6 times -6. We sometimes write them next to each other like this to show multiplication. So in factors language, this is 2 factors of -6. Now, notice up here to find the equation, well, what does this equal? If I multiply a negative times a negative, the result is positive. So 6 times 6 is 36, and a negative times a negative is positive. So -6 squared is positive 36. Okay, so just to go back here, if we don't have the opposite or negative sign in parentheses, we're not squaring that, and the result is negative. Okay. If we do have it in parentheses, then we are squaring the negative, and the result is positive. Now I just want you to see how you have to be careful about this on the calculator. Okay, so if you put the -6 Okay, so the calculator is thinking of it as 0 minus 6. And then square it, notice you get positive 36. Okay, but if we did the negative not in parentheses, then the 6, and then we hit the square button, the result is negative 36. Okay, so the calculator is doing this correctly, but if you want to find this result, if you don't put the negative 6 in parentheses, it's actually going to find the opposite of 6 squared. Okay, let's look at the next one. This is negative 5 to the third power. Well, this means 3 factors of negative 5. So that was factors language. We'll write that here. 3 factors of negative 5. Okay, so since the negative's in parentheses, in expanded form, it means negative 5 times itself 3 times. Okay, and the word name, we would write negative 5, either cubed, or we could say to the third power. So now let's see what this equals. Okay, so to find the product of 3 factors of 5, okay, so first we'll just multiply their absolute values. So 5 times 5 is 25. Then we have one more 5. 25 times 5 is 125. You could think of that as 5 quarters is 125 cents. Okay, and the negative times a negative is a positive, and then when we multiply by another negative, it's negative. So here, let's write this. Negative 5 times negative 5 is positive 25. Then we're really multiplying the positive 25 times a negative 5, which is negative 125. And just to take a quick look at a pattern here, because it's really useful. I would never write all of these negatives out as I was computing. Notice when we have an even number of negatives that we're multiplying, they cancel each other out. So every pair of negatives multiplied or divided equals a positive. Okay. Well, if you have an odd number, then 2 of them are going to cancel to a positive, and then the third one is going to make a positive times a negative, which is negative. So here we had 1 negative, the result is negative. 0 negatives, the result is positive. 2 negatives, the result is positive. 3 negatives, the result is negative. Okay, so you can use that pattern, and then you don't have to include negatives through all of your computations.